Hello, everybody, and welcome to another episode of Video Analytics 101. We are doing these kind of live interviews once per month as part of our podcast series, where we're interviewing industry leaders to talk about topics that usually we don't have the time to talk about when we have webinars. For example, last month we were talking with Hanwha about forensic search and edge analytics, and the month before we were talking with Onviv about Profile M. Both very exciting. If you haven't seen them, you can still watch the recording. You could go to YouTube or also Google Podcast, Apple Podcast, or Spotify. Just search for Video Analytics 101 and you can listen to the recordings. All right, but today we want to discuss AI chipsets in surveillance cameras. This is super exciting. Why? Well, in 2021, you saw that a lot of manufacturers came out with so-called AI cameras. But these AI cameras are usually based on dedicated chipsets that are dedicated for machine learning, for deep learning, or AI. And this is what we want to discuss, like how does the hardware look behind it? How do you combine it with software? How did you develop something like this? And what's so special about an AI chipset? And I'm very happy to have Mats Thulin here with me today. And I couldn't think of a better person to talk to about this, because Mats is the director of core technologies at Axis. And I think if there is someone that really knows what's going on in R&D at Axis, it's Mats. So Mats, welcome to the podcast.
Thank you, Florian. Really nice to be here.
So to start off, the reason why I'm so excited to talk to Mats, well, first of all, it's Axis. Axis is the largest manufacturer of surveillance cameras out there. But also Mats is from the R&D organization of Axis in Lund, which means that he's really at the core of what is being developed there. So we can talk about more insights and technical stuff. So to start us off, Mats, maybe you can tell us a little bit about your group. What's your mandate? How is it built up? And what are you doing in general?
Yep. So I've been with Axis almost 12 years now, and I'm working within R&D in Lund, but with a long-term R&D development, what we call technology development. So I've got 4 teams working in different topics. One team working with system-level aspects of surveillance, like bandwidth, security, etc. One of the team is working with video encoding and audio encoding, the team behind Zipstream, that is. And then I've got 2 teams working with AI or deep learning technologies and the technologies behind advanced analytics, which we are bringing out in the cameras.
So basically, out of 4 teams, 2 are dedicated to deep learning and AI.
Yep.
I mean, that's very a lot, really. So
Yep.
that's pretty cool. Maybe to dive a little bit into the topic, can you tell us, if we talk about AI chips or AI chipsets, what are we talking about? What's so special about this kind of chip?
So, as you know, I've been working with the ASIC development or system-on-chip development for all my career, actually. So, under Axis, we have a long tradition with our Artpick devices, which are the core of the cameras. And over time, having our own chipset and our own platform has enabled us to bring out innovations. So we really believe that focusing and development effort on the platform, hardware platform, is well worth. And things like Lightfinder, Zipstream, etc., wouldn't have been possible to do without our own internal chipset. So the last 4 or 5 years, we have seen more and more AI analytics coming out and moving from server and cloud down to edge devices. And to do that, we really need to have a hardware platform which really accelerates the AI algorithms on SOC devices. So that's where we talk about AI acceleration or AI chipsets.
So you design your own systems on chip, so SoC, SOCs, that are dedicated to speed up deep learning processes and that are specialized for inferencing of deep learning models, I guess.
Yes. So the Artpick platform contains a full system on chip. So it's all the things which you normally have in a camera, like image processing, etc. But on the same chipset, we have devoted a large region of the silicon area to accelerate hardware acceleration of deep learning compute. And with the new technologies we've seen in AI, with deep learning models, the compute need for that is really a stepping. And what previously you ran analytics on the CPU, now you need hardware acceleration of the analytics.
So, I mean, so in building this, what are challenges that you have to consider? I guess, as you're saying, analytics needs more and more processing power. I guess that puts some constraints on camera chips as well, no?
Yeah, and sometimes those constraints are not obvious, because as an AI developer, you normally you're used to a PC with a 200-watt GPU doing the calculations. So that's the kind of compute you're used to. And to squeeze that compute into a power envelope, in a camera we have a few watts, 3-4 watts of compute. And so it's the scaling of the compute to have a reasonable compute with the limited resources, power, thermal requirements on the camera. That's the main challenge. And I think we've seen a dramatic improvement in the capabilities of cameras over the last years. Much is historically through the more advanced processing nodes for ASICs. The Moore's law, giving you twice the performance on 18 months. Over the last 4 or 5 years, we've seen the Moore's law in ASIC slowing down. So currently, we don't get the same increases with the same cost. So today, one of the challenges is to have enough volumes on the cameras to be able to manage the cost of ASIC development in this.
And just for me to understand, going back to the heat development, the reason why this is a constraint is because otherwise it cannot fit into such a small housing, or
yes,
why do you have a heat constraint?
And many cameras are installed in thermally challenging environments, either outdoor environments where we have sunlight, or it could be indoor in enclosed environments. So there are two challenges. One is dissipating the power. The other one is since most of the cameras are power over the Ethernet, so supplying power to the camera is also a limitation.
Okay. Yeah, as you were saying, it nowadays it needs to scale your ASIC development. I mean, this brings me also to a obvious question right now that many people might be asking: How do you deal with global chip shortages? Does this affect you, or what do you do about it?
So the topic of supply and challenges in the supply chain pops up in many conversations around the industry today. And this is not specific to the AI chipsets. It's since those are critical components, actually those are less of a problem. What we see is, of course, simple things like components, plastic material, etc., which are challenging. And I know that this is not my field of expertise, but I know that the supply organization is focusing very much on that. But this is nothing specific to the surveillance industry. I think we've seen with the pandemic and some of the challenges around lockdowns, logistics situations where you have containers lacking around the world. Also, the very drastic change of demand. We've seen, for example, trying to get hold of a printer or a display the last year has been a challenge. So it's a global situation. Of course, we see extended lead times on some products, but we're in good company with the rest of the industry.
Okay.
And I think this is a challenge which will continue for quite some time. I guess one of the hottest topics during next year will be in the boardrooms and the management teams will be resilience, how to build resilient organizations and supply chains. So
Yes,
it's a challenge.
yeah, it's not only our industry, but also our industry that's very
Yeah.
affected.
Yes.
And I find it interesting that you're saying it's actually not so much the chips themselves for you, but components like plastic housing or
Yep.
so. It's surprising. Okay. So talking about concretely your chips, I know you just released Artpick 8 at
Yep.
GSX. Can you tell us a little bit about what's so different to the previous generations, to Artpick 7 or Artpick 6, and what is it really you're adding in terms of functionality and so on?
So with Artpick 8, there are a number of improvements, of course. Since we have the Artpick generations, we continuously improve in all areas. So there have been improvements in image processing and encoding processing, etc. But the main addition to this is that we've spent a lot of the resources on the silicon resources on a high performance deep learning acceleration unit. And it's not only that we have a specific hardware component to do acceleration, but to do this specifically for the kind of use cases and applications we're running, you need to target the acceleration of specific deep learning models, which are focused for the embedded world. So the typical deep learning models you have for a GPU or cloud, those need to be tuned and tweaked to fit within the limited power envelope. And then you
So,
need to have the specific hardware to accelerate them.
so are you saying, so you're not talking about small models like MobileNet or so, but yeah, rather tweaking larger models like YOLO for your envelope?
So, as you know, there are a number of open models, but with some specific characteristics. I think what we do is we take inspiration of some of the open research and try to tune that to our use cases and the hardware acceleration we have. But it's
Okay.
not only acceleration of the models, but it's also on a system level. You need to have the image quality, the image processing tuned for the deep learning engine. So without a good image processing, the algorithm and detections won't be on a high level. You need to sort of focus on the system level aspects on that. And having the full Artpick ASIC design in-house, the teams are much easier to collaborate on these system level aspects.
Okay. There actually is a conversation going on in the chat, and I just want to mention it because the question came if everything is done in Artpick 8 itself or if there's a coprocessor. And
So,
apparently the comment is not really.
so in specific products, we use coprocessors, but the Artpick products, Artpick 8 products, which we launched now, which is a dome camera and a fixed box camera, and the future Artpick 8 cameras, they will be a single SoC device. So the hardware acceleration of deep learning is within the Artpick 8 device. And the reason for that is mainly that having two silicon components that draws much more power. So to do it efficiently, you need to integrate into one device.
Okay, and I guess that's also one advantage that you do your own SoC, that
Yeah.
you can combine it because otherwise you could take off-the-shelf components and
Yes.
put them together.
But of course, since we have a broad portfolio, today we see a few products with this level of deep learning acceleration in the portfolio. But moving forward, all new products will be having a DLPU, which is the deep learning processing unit.
Okay.
So we will see the full portfolio having, of course, there will be different performance levels of deep learning. The more high-end products will have room for more power envelope, and therefore they will accelerate the deep learning models a bit more.
Yeah, today I think with older models you distinguish between the machine learning models and the deep learning models, right?
Yes. And as you know, the machine learning models based on a somewhat older technology have limitations, and that's the basic technology. What we see with deep learning models is a much more robust object detection, you're much more tolerant to invariance, rotations, lighting conditions, etc. So deep
But
learning models will be broadly deployed in the portfolio moving on.
yeah, so I guess at one point you will replace the machine learning ones with the deep learning models
Yeah.
going forward. Yeah.
Yes.
And I mean, considering that your group specifically deals with long-term stuff like long-term R&D, can you give us an idea for Artpick 8, for example? What's the runtime for this? So how long have you been working on this?
So, I mean, as everyone who's been working with ASIC development know, the lead times for development is quite long. We have multiple versions of Artpicks ongoing in development, different phases in development. And looking back, actually, when I started out as a project manager for Artpick 4. So I've been through a number of generations. So the cycle time is somewhere around 2 years for each generation.
Well, it's not too bad.
But I mean, today we're working with Artpick 9, Artpick 10 internally, and of course you need to have a vision on where the industry is moving, what is the future requirements on hardware platforms.
Okay. I mean, that's maybe a very good segue to talk about where do you think this is going in terms of hardware development, but also, of course, it's interesting your vision on how cameras and VMSs will work together in the future and
Yep.
how this will evolve.
So it's when we discuss AI and analytics, it's very easy to be visionary. Of course, what you see often on YouTube, etc., is the more visionary applications. And I think talking to that around AI and analytics in the surveillance industry, we should also be careful to have a reasonable expectation on the models, on the performance of analytics. It's always a balance between missing alarms and false alarms and the cost for false alarms. So with that sort of as a caveat, looking forward, with hardware acceleration on the deep learning models, we will see increasing performance on the underlying hardware acceleration, as we have seen before. But I think the advantage is also on a system level, so that you see hardware acceleration of specific models which are used in surveillance. So it's the combination of fine-tuning algorithms with the hardware acceleration and the system image processing together with analytics. That's where we will see the major improvements. Because the overall power envelope, for example, that's something which most likely we want to have a 200-watt camera broadly deployed. So that's where we see some of the advantages. And then I think today we have basic things like object detection and generating metadata. We will see increasing quality on those basic building blocks, but adding more functionality, more classes, more attributes, that's a given. But seeing more where we start to see key points and tracking not only objects, but behavior of objects. And in human behavior is the next step, which we want to address on edge devices. So as you saw when we launched Artpick 8, we at the same time launched our application development platform. I think what we will see moving forward is more and more applications being developed for specific use cases. So not only the basic use cases, but specific development for either a specific use case or a specific industry market. And then being able to run those applications on the camera has a lot of advantages. One is, of course, the scalability advantage, that in a system where you have 100, 200 cameras, if you're able to run the heavy lifting, the heavy processing on the cameras, that would offload a centralized server. So we will see more and more of these hybrid solutions where the heavy processing is done on the camera. Metadata is sent to a VMS or a server base where you do fine-tuning or more processing over a camera system, tracking between cameras, for example. So I think driving this, we need to have the platform to do applications which can run on edge and take advantage of the benefits on edge, like the image quality you get when running on the edge, but
Yeah.
also an open integration of the metadata into VMS.
I think one of the, as you were saying on YouTube, everything looks nice. But one of the challenges in practice with video analytics is as you mentioned, scalability.
Yeah.
Because in reality, we have many customers that want it on hundreds or even thousands of cameras. But once you get to deployment, it's not so easy anymore. Of course, it helps if it can run on the edge, but we also need to work on simplicity and ease of deployment.
Yes.
And that's why I think it's so cool, actually, that in the newest version of the ACAP, you support containers as well. So maybe there's a future where applications can run on the server or on the camera, or be deployed by a server on the camera.
Yes.
So that's very interesting, I think.
I totally agree, and that kind of to have the vision of a hybrid system, hybrid architecture, we need to remove the hurdles and make it very simple for a user to upgrade a system and to manage a system. I think working with open standards like a container platform, that's a way to enable that. And that enables also more well-known tools, which are well-known in the IT industry, how to manage a system of compute resources. So we're moving into a new era in that, and it's really exciting to see.
And you're absolutely right. A part of the new era that we also see with products that are born in the cloud and so on, we need to rely as much as possible on standards to be interoperable and really focus on the stuff we can do uniquely. We don't need to reinvent the wheel.
No.
But using standards is very important. Yeah.
I think this is aligned with the how Axis has worked. We've worked with the ACAP platform for the last 10 years something. Now we're remaking the platform to facilitate the AI, open standards, open libraries. But working with partners in an open collaborations, that's the way to jointly address the end customer uses, end customer needs.
Maybe that's a good point to take a final question from the chat. I'm not sure if you're the right person to ask this, but maybe you have an idea. So the question is, what does your validation process look like for ACAP-based applications? So I guess people who build these applications, how do you validate them?
So depending on what we mean with validation, the problem with AI applications is that the main thing you need to do is to test the application in a real environment. So in the ACAP platform, there are things like the tools, the stable APIs, and also mechanisms to make cybersecurity of applications self-contained. We don't have a validation process that we validate the application performance, because that's the expertise of the application development partners. So our best of breeds approach to this is to work with partners together with system integrators in each project, and jointly together look at what is the need for that specific project. We don't believe that you could packetize a niche application on a sort of a web page and just download it and it will work. We need to have the expertise for that niche in the real use case.
Yeah, I agree. We are already 10 minutes over the time that we wanted to take. Usually we try to keep it 15 minutes. But it was very interesting. Thank you, Mats, for joining.
Thank you.
It would be great to talk for a lot longer with you, because it's very insightful. But we want to keep these things short, so people get very short and packed information. So thank you for joining, Mats.
Thank you for having me. It's really
Otherwise,
nice.
Thank you everybody for joining this episode. As I mentioned, you can still rewatch that. It will be on YouTube. It will be on Spotify, on Google Podcasts, and Apple Podcasts. Otherwise, we are taking a break over Christmas, so there won't be an episode in December, but we have a very interesting one prepared for January already, and the one for February is also already in the works. So stay tuned, look around at LinkedIn for the invite. Otherwise, Thank you for joining and see you next time.